So this is example 3.6, and it actually points back to example 2.11, and there in example 2.11 what they said was they were looking at peak flow rates during storms in a storm sewer system. And so they had levels of precipitation. Okay, and those were the B, and that was equal to set B1, B2, B3, or low, medium, high. And then those were just coded as 1, 2, and 3. Okay, so that's what we would call categorical variables, even though we gave them numbers 1, 2, and 3. Those are just codes. They don't, 3 is not necessarily 3 times as big as 1 or 2 more than 1. It's just the numerical codes for low, medium, and high. And then similarly, we have A, which was A1 and A2, and those were, let's see, A1 was critical levels in the at the peak flow rate, and non-critical. And in general, we'll just say, oh, that's 1 and 2. Okay, so that's the background from example 211, and then in example 3.6, they say, well, we can write down this joint probability mass function. And so that's what they do. They say, okay, here's, they put the x on top like this and say 1, 2, 3, and then 1 and 2. And so x is B and y is A. And so they say, well, 0 probability there, 0.06, 0.12, 0.08, 0.24, and 0.5. And I check real quickly, there's 0.5, 0.06 and 0.24 is 0.3, so that's 0.8 total, and 0.12 and 0.08 is 0.2. That makes a total of 1. That makes a total of 1. Now we can also look here. So this this box is f of x and y, but now we could look at fy of y, and that would be 0.18 and 0.82, and we could look here at fx of x and just add these because we add across all y's, so we have 0.5, 0.3, 0.2, and of course they all add to 1. So we'll make these a little heavier lines here. And so we have our marginal distributions, and we could do that simply by adding across. For fy's, we just added across here. So we added across all x's, again across all x's, and we got the joint distributions. And in their example, they ask, oh, what's the probability of x being greater than y? And so x could be greater than y when? Well, this could be when x equals 2 and y equals 1, plus when x equals 3 and y equals 1, and plus when x equals 3 and y equals 2. So we could have those cases. We can look those up. X is 2, y is 1, that's 0.06. X is 3, y is 1, that's 0.12. And 3, 2, that's 0.08. And so that probability is 0.18, 0.26. Is that what they have? Oh, I looked at the wrong example. Sorry. They didn't ask for that. But if they did, that's what we would get, 0.26. And let's see. So they actually ask for what's the probability that y equals 1? Okay, well actually we have that right there as 0.18 because we already did it. Now if we hadn't, so this, one way to look at this is Fy of 1, which is 0.18. That's what we found. Can't get them, well, let's see, can I make it smaller? There, we can get them both on there. So there was our 0.18, that was our F1 of 1. But we could also get it by summing over the x's. So this would be, the sum of I equals 1 to 3 of f of I 1. And when we do that, we get our 0 plus 0.06 plus 0.12. Okay, we just get this row up here. We get the 0, 0.06, 0.12. And so that ends up being 0.18. Okay, and that is example 3.6.